Good afternoon, students. In the last class, we discussed the Hooke's law, right? So Hooke's law states that within the elastic limit, stress is directly proportional to the strain. Stress is directly proportional to the strain, right? So stress is nothing but the force which is acting per unit area. That is the restoring force or deforming force which is acting per unit area. So due to that force, so strain is produced in the material or in a body. So how we define strain means change in configuration to its original configuration, right? So the relation between the stress and strain is given by Hooke's. So the statement is within the elastic limit, the stress is directly proportional to the strain, right? So in this class, we are going to discuss about stress strain curve. So that means we are discussing or we are plotting the graph for the stress and strain curve. So to discuss the stress and strain, we are considering a material, so that we are going to study under the tensile stress, right? So that material either maybe a rod or it may be a thin wire, right? So we consider that material as one wire. So one end of the wire is fixed to the rigid support. So this indicates what the rigid support. To this rigid support, we consider one thick wire, right, of length L. To discuss the stress strain curve, we are considering one thick wire, right? So this is wire, right? So we can consider wire or any material. So here I am going to consider the thick wire. So here onto this wire we are applying the tensile stress. So what is tensile stress? So tensile stress is the type of the normal stress. That means we are applying the load or force to the area of cross section perpendicularly. So ಯಾವುದಾದ್ರು ಒಂದು area of cross section ಅಥವಾ area ಗೆ surface ಗೆ perpendicular ಆಗಿ ನಾವು ಏನು apply ಮಾಡ್ತಾ ಇದೀವಿ, force ನ apply ಮಾಡ್ತಾ ಇದೀವಿ, right? So that is the wire is under tensile stress. So due to this tensile stress, so there is a change in configuration of the wire. That means the length of the wire increases. So that is tensile strain, right? So here we are applying the load. So due to this load, there is a change in configuration, right? So which configuration? That is length. So due to the tensile stress, so length increases. That means strain. So which strain that is? The tensile strain. So tensile strain is produced in the wire. That is because of the tensile stress. That is the deforming force which is applying normal to the area of cross section, right? So by considering this case, we are going to discuss the stress and strain curve. So ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ತುಂಬಾ ಥಿಯರಿ ಇದೆ. ಸೊ ಯು ಕ್ಯಾನ್, ಇಫ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್, ಯು ಕ್ಯಾನ್ ರೈಟ್ ಬೈ ಯುವರ್ ಓನ್ ವರ್ಡ್ಸ್, ರೈಟ್? So the graph is along y-axis we taken stress and along x-axis we taken strain. So the graph between stress and strain, so strain is taken along x-axis and the stress is taken along y-axis, right? So to study the stress and strain, so already Kelly Prakara, to discuss the stress and strain, we considered one material. So a material thin rod irbodu athwa wire irbodu. So here I am considering the wire. Now we are subjected this wire to the tensile stress. To which stress we are subjected? To the tensile stress. So you know the meaning of tensile stress. So tensile stress means increase in length when the force is acting perpendicular to the cross section area. So in cross section area age perpendicular ಆಗಿ ಏನಾಗ್ತಾ ಇದೆ, force act ಆಗ್ತಾ ಇದೆ. So due to this tensile stress, there is a change in configuration in length. So that is the tensile strain. Right? So up to now we discussed about tensile stress, tensile strain. So now the relation between the stress and the strain. So For example, initially I am applying the force that is some 2 Newton, right? So some 2 Newton ಅಷ್ಟು force ನ apply ಮಾಡ್ತಾ ಇದ್ದೀನಿ, that is the deforming force. So due to this force there is a change in length. So length change ಆಗ್ತಿದೆ, so that is also a small amount. So small amount ಅಷ್ಟು length change ಆಗ್ತಿದೆ, so we can take that one as some 0.1. So strain ಎಷ್ಟು change ಇದೆ ಅಂದ್ರೆ 0.1 ಅಷ್ಟು change ಇದೆ, right? So this is what the delta L, right? So due to the tensile stress, so there is a change in strength. So for example, I am explaining here. So initially we are applying 2 Newton load or deforming force. So due to that force there is a change in the configuration in length. So how much it is changing? So that change is some 0.1. So meter or centimeter. So centimeter 0.1 centimeter ಅಷ್ಟು length ಏನಾಗಿದೆ increase ಆಗಿದೆ, right? So now again I am increasing the load. So next time ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಾನು load ನ increase ಮಾಡ್ತಾ ಇದ್ದೀನಿ by 4 Newton. So 2 Newton ಇದ್ದಿದ್ದು load ನ next time ಮಾಡ್ತಾ ಇದ್ದೀನಿ 4 Newton ಗೆ increase ಮಾಡ್ತಿದ್ದೀನಿ. So when the load increases, again the tensile strain also increases, right? So 0.1 centimeter ಇದ್ದಿದ್ದು 0.2 centimeter ಅಷ್ಟು increase ಆಗುತ್ತೆ. So further again if I increases the load by 6 Newton, so the strain also increases, that is 0.3 centimeter. So if we observe this, so we can say that the force is linearly increasing. That means deforming force is linearly increasing with that of the strain, right? So length kuda enagtide linear agi increase agtide. So when we say that the linear increase, so there is a change in load equal proportional idre, so that the change in length kuda namage equal proportion irಬೇಕು, right? So 4 minus 2, there is a change in 2 Newton, so 0.2 minus 1 is 0.1 centimeter, right? So 6 minus 4 again 2 Newton, so 0.3 minus 0.2, again we are getting 0.1 centimeter. So that means, so linear again force increase ಆಗ್ತಾ ಇದೆ, that is the deforming force. That means the tensile stress is linearly increasing, that is load is linearly increasing. So then corresponding strain also linearly increasing, right? So hence we plot the curve for the stress and strain, we getting the linear curve that is starts from 0, that is starts from the origin O, right? So why? Because initially the force is 0 Newton. So here there is no force is acting, then there is no strain, right? So that means when stress is equals to 0, then strain is also equals to 0, right? So when stress is equals to 0, strain is equals to 0. That means ಯಾವುದೇ ತರದ್ದು ನಾವು ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ತರದ್ದು ಸ್ಟ್ರೆಸ್ ಇರೋದಿಲ್ಲ. ಸೊ ಯಾವುದೇ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ್ದು ಸ್ಟ್ರೈನ್ ಇರೋದಿಲ್ಲ, right? So hence we are getting the linear curve that starts from the origin, that is from the 0, right? So in general we can plot one straight line, right? Right, from 0 to A. So the from the region from 0 to A, it obeys the Hooke's law. Why? Because stress is directly proportional to strain, that is region from 0 to A. So in this region, that is from 0 to A, stress is directly proportional to strain. When stress is equals to 0, strain is equals to 0, right? So that means linear. So 2 Newton force act ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ 0.1 centimeter. This is just for an example. So ಅರ್ಥ ಆಗೋ ಪರ್ಪಸ್ ಗೆ ಇದನ್ನ ಬರ್ದಿರೋದು, right? So 2 Newton act ಆಗ್ತಿದೆ ಅಂದ್ರೆ 0.1 centimeter ಅಷ್ಟು increase ಆಗ್ತಿದೆ. 4 Newton act ಆಗ್ತಿದೆ ಅಂದ್ರೆ 0.2 centimeter ಅಷ್ಟು increase ಆಗ್ತಿದೆ. So likewise, if we increase the load to this wire, the same proportional, so same range ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, length ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So the region from 0 to A, so up to this point it behaves as a elastic material, right? So this wire behaves as a elastic material, right? So in this region it obeys the Hooke's law, or you can make points like region, right? So in region from O to A. So from point O to point A. So when stress is equals to 0, strain is equals to 0, right? So it obeys Hooke's law. So obeys Hooke's law means again stress is directly proportional to the strain, right? So and the next point is material. So this is only for this region, that is from 0 to A. So material in this region behaves as elastic material, right? So that means when we remove the deforming force, the configuration will regain to its original configuration. So here namge increase agide length, that will comes back to its original position, right? So that comes under the Hooke's law, right? So that is material behaves as a elastic, right? So that means up to this region the material, so in this region alli ನಾವು ಯಾವುದೇ ಪಾಯಿಂಟ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಈ material, that means this wire behaves as elastic, right? So the property of the elastic, that is from the definition ಏನು ಹೇಳುತ್ತೆ ಅಂದ್ರೆ, when we remove the deforming force it regains its original configuration, right? So when it reaches to its original configuration, then those materials are called elastic materials, right? So here wire behaves as elastic material in the region from 0 to A. So ಈ region ಅಲ್ಲಿ ಈ wire ಯಾವ ತರ behave ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ elastic material ತರ behave ಮಾಡ್ತಾ ಇದೆ, right? So that are, so these are the 3 points which comes under for the region from 0 to A, right? So 0 to A means when the load increases, that means tensile stress increases. So due to this tensile stress there is a tensile strength, so this material produces a tensile strength, right? So that stress, so now stress ಗೆ ಎಷ್ಟು values ನ increase ಮಾಡ್ತಾ ಹೋಗ್ತೀವೋ in the same proportion strain ಕೂಡ increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So hence when stress is equals to 0, strain is equals to 0. So it obeys the Hooke's law. It obeys the Hooke's law means, so we are getting the linear curve. So strain ಎಷ್ಟು increase ಆಗ್ತಾ ಹೋಗುತ್ತೋ stress ಕೂಡ ಅಷ್ಟೇ increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. And the third point is when we remove deforming force, the object, the wire will come back to its original length, right? So after removal of the deforming force, so hence in the region from 0 to A the wire behaves as elastic material or exhibits the elastic nature, right? So next further if we increase the load, so up to 6 Newton agide. So this is just for an example, so iduna example ತಗೊಂಡು explain ಮಾಡ್ತಾ ಇರೋದು, right? So next if we increase the load, so to some 8 Newton, then again there is a change in configuration, length ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ further increase ಆಗುತ್ತೆ. So that is by some 0.4 centimeter, right? So that means linearly increase ಆಗುತ್ತೆ. Further if we increase the load to some 10 Newton, then there is a change in configuration, that is length increase ಆಗ್ತಿರೋ value ಅಲ್ಲಿ ಏನು change ಆಗ್ತಿದೆ. So 0.4 ಇದ್ದಿದ್ದು ಏನಾಗುತ್ತೆ some 0.45 centimeter ಅಷ್ಟು increase ಆಗುತ್ತೆ, right? So if it further increases some 12 Newton, then again it changes to some 0.55 centimeter, right? So if we observe these values, so up to 6 Newton the line curve which we are getting, that one is the linear curve, that is the straight line. So strain as increase ಮಾಡ್ತೀವೋ stress ಕೂಡ ಅಷ್ಟೇ change ಆಗ್ತಾ ಹೋಗುತ್ತೆ. But after 6 Newton, so 8 Newton apply ಮಾಡಿದ್ರೆ ನಮಗೆ 0.4 centimeter ಇದೆ. So next 10 Newton apply ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಅಲ್ಲಿಗೆ 0.45. So here there is no linear increase. So ಇಲ್ಲಿಂದ change ಎಷ್ಟಾಗುತ್ತೆ 0.05 ಅಷ್ಟು vary ಆಗ್ತಾ ಇದೆ. Further here it varies from 0.10. That means linear ಆಗಿ increase ಆಗ್ತಾ ಇಲ್ಲ, right? So that is from the region. So here we getting like this. So this is B. So that point is B point, right? So from that is in from A to B. So in the region from A to B. So illivargu study ಮಾಡಿದ್ದೇವೆ from 0 to A, right? So now from region A to B. So here what we are observing. So when stress is equals to 0, so strain ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ 0 when after remove the deforming force. So this is when after removal of the deforming force, right? So when after removal of the deforming force, so the increase in length will, that is change in configuration, will regain its original configuration, right? Increase ಆಗಿರುತ್ತೋ ಅದು ಮತ್ತೆ return ಹೋಗುತ್ತೆ, right? So that means after removal of the deforming force, when stress is equals to 0, strain is equals to 0. So here also in this case also stress is equals to 0, strain is also equals to 0, right? So the next point is it does not obeys the Hooke's law. So it does not obeys the Hooke's law means, so linearly stress is not directly proportional to strain, right? So stress is not directly proportional to strain means it does not obeys the Hooke's law, right? Why? Because so stress Hooke's law ಏನು ಹೇಳ್ತಾ ಇದೆ ನಮಗೆ, ಲೀನಿಯರ್ ಆಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಸ್ಟ್ರೆಸ್ ಅಲ್ಲಿ ಲೀನಿಯರ್ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು ಅಂದ್ರೆ ಸ್ಟ್ರೈನ್ ಅಲ್ಲಿ ಕೂಡ ಲೀನಿಯರ್ ಆಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕಾಗಿತ್ತು. ಬಟ್ ಇಲ್ಲಿ ನಮಗೆ ಸ್ಟ್ರೆಸ್ ಅಲ್ಲಿ ಲೀನಿಯರ್ ಆಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ, ಬಟ್ ನಾಟ್ ಇನ್ ದ ಸ್ಟ್ರೈನ್. ಸೊ ಇನ್ ದ ಸ್ಟ್ರೈನ್ ಅಲ್ಲಿ ನಮಗೆ ಒನ್ ಟೈಮ್ 0.05 ಬರ್ತಾ ಇದೆ, ಅನದರ್ ಟೈಮ್ 0.10 ಬರ್ತಾ ಇದೆ. ಸೊ ಫರ್ದರ್ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So here the strain is not exactly equals to 0, but it is approximately equals to 0, right? So when removing of the deforming force, it will not regain its original configuration. So exact agi namge 10 centimeter ಇದೆ ಅಂದ್ರೆ it will not go up to the 10 centimeter. So some little bit variation irutte. So that's why the strain is approximately equals to 0, not exactly equals to 0. This is when after removal of after removal of deforming force, right? So stress is equals to 0, strain is also equals to 0. So here also after removal of deforming force, so when we remove the deforming force, so remove ಮಾಡಿದ ರಿಮೂವ್ ಮಾಡಿದ ತಕ್ಷಣ ಅಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ್ದು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರಲ್ಲ, ದಟ್ ಮೀನ್ಸ್ ಯಾವುದೇ ತರದ್ದು ಸ್ಟ್ರೆಸ್ ಇರಲ್ಲ. ಸೊ ಹೆನ್ಸ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ. ಸೊ ವೆನ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ 0, the strain value will equals to 0, but here in this case, that is from region A to B, it will not go up to 0. So but it has some value, so hence strain is approximately equals to 0, right? So next point is it does not obey Hooke's law. So it does not obey Hooke's law means the curve which we are getting is not linear. So ಇಲ್ಲಿ observe ಮಾಡಿದ್ರೆ curve ಏನಾಗಿದೆ ನಮಗೆ ಸ್ವಲ್ಪ bend ಆಗಿದೆ. So this indicates what, the stress is not directly proportional to the strain, right? So there is some change in the strain. So ಇಲ್ಲಿ length increase ಆಗಿದ್ಮೇಲೆ after remove deformed force ನ remove ಮಾಡಿದ್ಮೇಲೆ ನಮಗೆ original length ಬರೋದಿಲ್ಲ, only small change ಆಗುತ್ತೆ. So ಅದಕ್ಕೋಸ್ಕರನೇ ಅಲ್ಲಿ ನಮಗೆ strain ಅಲ್ಲಿ ಏನು ಬರ್ತಾ ಇದೆ, there is a bend, right? So that point B we call as yield point, right? So B point na ನಾವೇನಂತ ಕರಿತೀವಿ, yield point ಅಂತ ಕರಿತೀವಿ. So A point na ನಾವೇನಂತ ಕರಿತೀವಿ, elastic limit. So point A is the elastic limit and the point B we call as yield point, right? So not the elastic limit, it is the proportional limit. Why? Because it is proportional, right? proportional limit. So this is yield point or elastic limit. Right? So why we are calling point A as proportional limit means stress is directly proportional to strain. That is, it obeys the Hooke's law. Hence, we call up to the point A is called as the proportional limit. So, ಈ point ವರೆಗೂ ನಾವು ಯಾವುದೇ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡೋದು ಸ್ಟ್ರೆಸ್ ಯಾವುದಕ್ಕೆ ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿರುತ್ತೆ ಸ್ಟ್ರೈನ್ ಗೆ ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿರುತ್ತೆ ರೈಟ್ ಸೊ ದ ಪಾಯಿಂಟ್ B we call as so this point B is called as elastic limit and the corresponding stress. So ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಮಗೆ ಏನು ಸ್ಟ್ರೆಸ್ ಬರುತ್ತೋ ಸೊ ಆ ಸ್ಟ್ರೆಸ್ ನ ಏನಂತ ಕರೀತೀವಿ that we call as yield strength ಅಂತ ಕರೀತೀವಿ right so the corresponding stress we call as yield strength right so that point we call as yield strength. So proportional limit ಗೆ corresponding stress. So ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಮಗೆ ಎಷ್ಟು ಸ್ಟ್ರೆಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ yield strength ಅಂತ ಕರಿತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹಿಯರ್ 12 ನ್ಯೂಟನ್. ಸೊ 12 ನ್ಯೂಟನ್ ಇಂದ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ ವ್ಯಾಲ್ಯೂಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಸೊ yield strength ಎಷ್ಟಿರುತ್ತೆ ಅಂದ್ರೆ 12 ನ್ಯೂಟನ್ ಇರುತ್ತೆ ರೈಟ್ ಸೊ ದಿಸ್ ಇಸ್ ದ corresponding stress right so stress as the stress to the corresponding yield point we call as yield strength right. So that yield strength is denoted by sigma y. So sigma y is the yield strength, right? So next, further if we increase the load, so further ಏನು ಮಾಡ್ತಾ ಇದೀವಿ ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಲೋಡ್ ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ for the small increase in load, right? So small increase load ಮಾಡಿದ್ರೆ so that is 12 newton ಇದೆ just regular 2 newton difference ಅಲ್ಲಿ small load na apply ಮಾಡಿದ್ರೆ we are getting the strain so drastic change in the strain means we getting large strain so that means 1.55 centimeter as to strain getting only for the small change in stress so only for the 2 newton as to difference iro stress ige so ನಮಗೆ ಎಷ್ಟು ಸಿಗ್ತಾ ಇದೆ strain 1.55 centimeter that means we are getting the length that is large length so ಇಲ್ಲಿವರೆಗೂ ನಮಗೆ ಏನು ಬರುತ್ತೆ strain right so that we can indicate in the graph like this right so only for the small change in stress right so this point so here one more point that is C in between B and D you can take that point as D point right so stress ಕರ್ವಲ್ಲಿ ಇಷ್ಟು stress change ಆಗಿದೆ but strain ಅಲ್ಲಿ very large proportional ಆಗಿ ನಮಗೆ ಏನು change ಆಗ್ತಾ ಇದೆ strain change ಆಗ್ತಾ ಇದೆ right so that is from the region from B to D right for a small change in stress we are getting the large strain right so here one more point becomes one point as E right so here we are getting 5 points so A is the proportional limit B is the yield point or elastic limit then C D E now we are going to discuss on point C point D and E right right so further if we increase the load then tensile stress increases and also for a small change in the tensile stress there is a large change in the tensile strength so for a small change in tensile stress so ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಸ್ವಲ್ಪ ಲೋಡ್ ಗೆ ಎಷ್ಟು ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿ ನಮಗೆ ಸ್ಟ್ರೈನ್ obtain ಆಗ್ತಿದೆ so here it does not obeys the Hooke's law so in this region that is from the region B to D so here it will not exhibit the Hooke's law why because after removal of the deforming force so it will not get back to its original configuration right so after removing of the deforming force. So ನಮಗೆ actually deforming force ನ ತೆಗೆದ ತಕ್ಷಣ ಏನಾಗ್ತಾ ಇತ್ತು, it will come back to its original position ಬರ್ತಾ ಇತ್ತು. But after removing of the deforming force, the strain will not equals to 0, right? So stress 0 ಆಗ್ತಿದ್ದಂಗೆನೆ strain ಏನಾಗಬೇಕಾಗಿತ್ತು, ನಮಗೆ 0 ಆಗಬೇಕಾಗಿತ್ತು. But here in this case, strain is not equals to 0. That is from region 4 B to D. So from the region B to D, right? So in this region, after removing of the deforming force, right? So after removal of deforming force, so after removal of deforming force, nothing but applied force na remove ಮಾಡ್ತಾ ಇದೀವಿ. That means there is no stress, because force ಇಲ್ಲ ಅಂದ್ರೆ stress ಏನಾಗುತ್ತೆ, 0 ಆಗುತ್ತೆ, right? So stress is equals to 0 but not strain. So strain is not equals to 0, right? So that means it will not go back to its original configuration, right? So adu original configuration ke hogta illa, then the wire behaves as the plastic material, right? So in the region O to A, it behaves as the elastic property. So after the removal of the deforming force, it will not get back to its original configuration. Then the wire has, so wire ಯಾವ ತರ behave ಆಗ್ತದೆ ಅಂದ್ರೆ plastic. That means it will not regain its original configuration, right? So the next proper point is it does not obey Hooke's law. So the next point in the region from B to D, so it does not obey the Hooke's law. And the last point is it behaves as plastic material. So it means wire. So this wire behaves as a plastic material. So this is the region. So up to this region, it has the elastic property. So from region O to B, it has the elastic property. Then from B to D, it behaves as a plastic property. So it exhibits the plastic property. So it exhibits plastic property means it will not regain its original configuration, right? So next, the point which comes under between B and D, right? So B and D, in between B and D, we are getting one point. So in this point, the length or elongation of the wire is fixed, right? So after removal of the deforming force, so deforming force na remove ಮಾಡ್ತಾ ಇದ್ದಂಗೆ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಆ ಲೆಂತ್ ಎಲ್ಲಿ ಎಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಆಗಿರುತ್ತೋ, so in the long, right? So ಅದು maximum variation ಆಗುತ್ತೆ. For a small stress, we are getting the large elongation or large strain, ತುಂಬಾ large strain ಸಿಗ್ತಾ ಇರುತ್ತೆ. So in that middle one point we are getting, so that point we taken as permanent set, right? So up to that permanent set, it will come back to its original position. So adu original position ಗೆ ಬರ್ತಾ ಇರುತ್ತೆ, but ಏನು ಅಂದ್ರೆ exactly it does not obey the Hooke's law. So ಎಷ್ಟು ಸ್ಟ್ರೆಸ್ ಇರುತ್ತೋ ಅಷ್ಟು ಸ್ಟ್ರೈನ್ ಸಿಗೋದಿಲ್ಲ, ಜೊತೆಗೆ deforming force ರಿಮೂವ್ ಮಾಡಿದ ತಕ್ಷಣ original configuration ಗೆ ಬರೋದಿಲ್ಲ, right? So this permanent set is nothing but after removal of the deforming force, that wire will not come back to its original configuration, right? So deforming force remove ಮಾಡಿದ ತಕ್ಷಣ ಅದು original configuration ಗೆ ಬರೋದಿಲ್ಲ, ಅದು set ಆಗುತ್ತೆ. So the wire will stretch as is after removal of the deforming force. So that is the condition. So when stress is equals to 0, strain is not equals to 0. That means there is some strain in the wire. So wire ಏನಾಗುತ್ತೆ, ತುಂಬಾ ಲೆಂತ್ ಆಗುತ್ತೆ, right? So after, that is in the region as the region lies between the point C and D, right? As brittle. So our region ಏನಿದೆ ನಮಗೆ brittle ಇದೆ. So if we further increases the load behind the point D, so ಈ D point ಆದ್ಮೇಲೆ ನಾವು further load ನ increase ಮಾಡಿದ್ರೆ so the wire will breaks down. So wire ಏನಾಗುತ್ತೆ ನಮಗೆ ಕಟ್ ಆಗುತ್ತೆ. So ಅದು ಯಾವ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ಕಟ್ ಆಗಬಹುದು, right? So that point is the E point. Right, so if we apply the load behind the point D, so east point ಆದ್ಮೇಲೆ next ನಾವೇನಾದ್ರು load apply ಮಾಡ್ತಾ ಹೋದ್ರೆ so there is a sudden changes in the strength and the wire will break down. So ಈ wire ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ ಕಟ್ ಆಗುತ್ತೆ, right? So that point E is the last point, that is the fracture point. We call that point E as fracture point. So fracture nothing but breakdown. So ಅಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ wire ನಮಗೆ breakdown ಆಗುತ್ತೆ, right? So initially small loads apply ಮಾಡ್ತಾ ಹೋದಂಗೆಲ್ಲ linear ಆಗಿ strain ಕೂಡ increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So deforming force removal ಆಗಿದ ತಕ್ಷಣನೇ ಮತ್ತೆ ಅದು ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಗೆ ಹೋಗುತ್ತೆ. So after certain limit, so ಯಾವ ಲಿಮಿಟ್ ಅಂದ್ಮೇಲೆ elastic limit. So after the elastic limit, if we apply the force, apply the force again, the strain will increases, but when we remove the deforming force it will not get back to its original configuration. So deforming force remove ಮಾಡಿದ್ಮೇಲೆ ಅದು ಮತ್ತೆ original configuration ಗೆ ಹೋಗೋದಿಲ್ಲ, right? So if we further increases the load only for the small amount of the load, we are getting the maximum strain. That means drastic changes in the strain. We are getting very long elongation, right? So small force ಗೆ ನಮಗೆ ಏನು ಸಿಗ್ತಾ ಇದೆ, maximum strain ಸಿಗ್ತಾ ಇದೆ. So hence that's why we are getting the long curve. So this indicates what? The strain. Only for this small amount of stress we are getting the long strain, right? So after we apply the force or load behind the point D, so ಈ point D ಆದ್ಮೇಲೆ ಕೂಡ ನಾವೇನಾದ್ರೂ force apply ಮಾಡಿದ್ರೆ so ಅಲ್ಲಿಗೆ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ, there will be a fracture in the wire. So fracture is nothing but the breakdown. So wire ಏನಾಗುತ್ತೆ ನಮಗೆ ಕಟ್ ಆಗುತ್ತೆ. So that point is the fracture point, right? So in the region between point C and E, so between point C ಮತ್ತು point E region ಅನ್ನ ನಾವು ಇಲ್ಲಿ ಏನಂತ ಕರೀತೀವಿ ಅಂದ್ರೆ ductile, right? So the point between C and D is the brittle point, so that is the breakdown. So point C and E ನ ನಾವೇನಂತ ಕರೀತೀವಿ, ductile ಅಂತ ಕರೀತೀವಿ, right? This one is the ductile and this is so point C to D we call that one as the ductile and C to E is the brittle, right? So this is about the stress strain curve. So stress strain curve na study ಮಾಡಬೇಕು ಅಂದ್ರೆ consider one wire, so they are applying the tensile stress. So due to this tensile stress there is a tensile strain. So in general ಆಗಿ stress ಇರುತ್ತೆ ಜೊತೆಗೆ strain ಇರುತ್ತೆ. So the fact is we are applying the load, that is the deforming force. So deforming force apply ಮಾಡ್ತಾ ಹೋದಂಗೆಲ್ಲ ನಮಗೆ ಈ ವೈರ್ ಅಲ್ಲಿ ಏನು ಚೇಂಜಸ್ ಕಾಣ್ತಿದೆ ಅನ್ನೋದನ್ನ, right? So the stress strain curve is different for different materials. So ಈ curve ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ ಈ ಮೆಟೀರಿಯಲ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. So different materials having different curves. So ನಮಗೆ different material ಗೆ different curves ಇರುತ್ತೆ. So ಕೆಲವರಲ್ಲಿ ductile point ಕಮ್ಮಿ ಇರುತ್ತೆ, ಕೆಲವರಲ್ಲಿ elastic limit ಜಾಸ್ತಿ ಇರುತ್ತೆ, right? So that depends on the material. So ಈ material ಮೇಲೆ ನಮಗೆ ಆ curve ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, change ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So this one is the general curve for the stress and strain. So ಇದು general ಯಾವುದೋ ಒಂದು ಮೆಟೀರಿಯಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿರೋದ್ರಿಂದ we are getting the curve in this pattern, right? So ಈ pattern ಅಲ್ಲಿ ನಮಗೆ curve ಬರುತ್ತೆ, but ಇದರ length increase ಅಥವಾ decrease stress variation ಆಗೋದು ಅದೆಲ್ಲ ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ material of the wire ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, right? So here some definitions are there. So the first one is elastic limit. So what is elastic limit? So elastic limit is the maximum stress up to which the body can obey the Hooke's law. So elastic limit anta enu andre, so this is the limit to up to which the maximum stress, so maximum stress apply ಮಾಡಿದಾಗ it obey the Hooke's law. So ಮ್ಯಾಕ್ಸಿಮಮ್ ಸ್ಟ್ರೆಸ್ ವರ್ಗೂ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಏನಾಗಬೇಕು ನಮಗೆ ಸ್ಟ್ರೈನ್ ಲೀನಿಯರ್ ಆಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು. ಸೊ ಫ್ರಮ್ ದ ರೀಜನ್ ಎ ಟು ಬಿ ಕೂಡ ನಮ್ಗೆ ಏನಾಗ್ತದೆ, ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು ಇಟ್ಸ್ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಬಟ್ ನಾಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಈಕ್ವಲ್ಸ್ ಟು ಸ್ಟ್ರೈನ್. ಸೊ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿ ಇರೋದಿಲ್ಲ, ಬಟ್ so that point B we call as the elastic limit, right? So the definition, elastic limit, right? So what is elastic limit? It is the maximum stress, it is the maximum stress up to which Hooke's law is obeyed, right? So ಎಲ್ಲಿವರೆಗೂ ನಮಗೆ Hooke's law obey ಆಗುತ್ತೋ, ಸೊ ಅಲ್ಲಿವರೆಗೂ ಎಷ್ಟು ನಾವು ಸ್ಟ್ರೆಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವೋ ಅದಿಷ್ಟನ್ನು ನಾವೇನಾಗ ಕರಿತೀವಿ, ಆ ಪಾಯಿಂಟ್ ಗೆ ಏನಾಗ ಕರಿತೀವಿ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಪಾಯಿಂಟ್. ಸೊ Hooke's law ಎಲ್ಲಿವರೆಗೂ obey ಮಾಡುತ್ತೋ ಅದನ್ನ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪಾಯಿಂಟ್ ನಾವೇನಾಗ ಕರಿತೀವಿ, ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಆರ್ yield ಪಾಯಿಂಟ್ ಅಂತ ಕರಿತೀವಿ, right? Next one is the, so this point is the tensile strength, right? So after D it will fracture, so hence we call that one as the tensile strength, right? So what is tensile strength? The minimum stress needed to cause fracture the material. So ನಮಗೆ ಕಡಿಮೆ ಸ್ಟ್ರೆಸ್ ಅಲ್ಲಿ ಮೆಟೀರಿಯಲ್ ಏನಾಗುತ್ತೆ, ಫ್ರಾಕ್ಚರ್ ಆಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಇಫ್ ವಿ ಅಪ್ಲೈ ದ ಲೋಡ್ ಅಬೋವ್ ದಿಸ್ ಪಾಯಿಂಟ್, ಸೊ ಈ ಪಾಯಿಂಟ್ ಇಂದ ನಾವು ಎಷ್ಟು ಲೋಡ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತೀವೋ ಅದು ಆ ಲೋಡ್ಸ್ ಎಲ್ಲದಕ್ಕೂ ಯಾವ್ದಕ್ಕೆ ರೀಸನ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ ಈ ಮೆಟೀರಿಯಲ್ ಫ್ರಾಕ್ಚರ್ ಆಗೋದಕ್ಕೆ ರೀಸನ್ ಆಗಿರುತ್ತೆ. ಸೊ ಅಂತ ಪಾಯಿಂಟ್ ನಾವೇನಂತ ಕರಿತೀವಿ, ಟೆನ್ಸೈಲ್ ಸ್ಟ್ರೆಸ್ strength. That means the minimum stress which is needed to cause the fracture of the material, right? So that we call as the tensile strength, right? Next one is the brittle, right? So what is brittle? That is material fractured soon after elastic limit is crossed, right? So that we call as the brittle, right? So example for the brittle, concrete, glass. So glass ಕೂಡ ಅಷ್ಟೇ, ಸೊ ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಕ್ರಾಸ್ ಆಗ್ತಿದ್ದಂಗೆ ಅದೇನಾಗುತ್ತೆ, ಬ್ರೇಕ್ ಆಗುತ್ತೆ, right? So on the next one is ductile. This is brittle and this one is ductile, right? So next one is ductile, right? So ductile is the material having permanent set, material having the permanent stretch without breaking, right? So ductile is the material which having the permanent stretch without breaking, right? So example, steel. So steel is the example for the ductile, right? So copper, aluminum, Right. So these are the few definitions which comes under the stress strain curve. Right. So stress strain curve na study ಮಾಡಬೇಕು ಅಂದ್ರೆ initially we considered one wire. So wire or a rod. So metallic rod ಅಥವಾ wire na considered ಮಾಡಿದೀವಿ. So that wire is subjected to the tensile stress. So tensile stress is nothing but force which is acting perpendicular to the area, right? So perpendicular to the surface area ಗೆ force act ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ tensile stress. Due to this tensile stress there is a strain produced in the wire. So ಈ tensile stress ಇಂದ ನಮಗೆ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ strain ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ. So by varying the load or force. So ಈ force deforming force na vary ಮಾಡ್ತಾ ಹೋದಾಗೆಲ್ಲ ಏನೇನ್ changes ಕಾಣುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು region by region na discuss ಮಾಡಿದ್ವಿ, right? So from region 0 to A it obeys the Hooke's law. That means stress is directly proportional to strain. So strain na stress linear ಆಗಿ increase ಮಾಡ್ತಾ ಹೋದ್ರೆ strain ಕೂಡ linear ಆಗಿ increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Next, from point A to B for a small change load, that is applied load, so stress change ಆಗ್ತೋದಂಗೆಲ್ಲ strain ಕೂಡ change ಆಗುತ್ತೆ, but it will not be in linear. So here in this region from A to B it does not obey the Hooke's law, right? So even though it is nearer, so after removing of the deforming force it will come back to its original state, but exactly stress is not equals to, that is strain is not equals to 0, right? So hence this region, so this point we call as elastic limit. So within this elastic limit the material behaves as elastic in nature. So after this elastic limit the material behaves as plastic in nature, right? So after further increasing the load, for the small increasing load we are getting the maximum strength, so that we are observed from the curve B to E. So here we are getting the maximum strain. That means length tumba increase agide only for the small stress. So small stress here we are getting the maximum strain, right? So in this region after removing of the deforming force the wire will not get back to its original configuration. That means stress is not directly proportional to the strain. So deforming force na remove ಮಾಡಿದ ತಕ್ಷಣನೇ ಅದೇನಾಗೋದಿಲ್ಲ, it does not go back to its original configuration. So ಅಂತ ಪ್ರಾಪರ್ಟಿ ನಾವೇನಂತ ಕರಿತೀವಿ ಪ್ಲಾಸ್ಟಿಕ್ ಅಂತ ಕರಿತೀವಿ ಅಥವಾ ಪ್ಲಾಸ್ಟಿಸಿಟಿ ಅಂತ ಕರಿತೀವಿ, right? So this region from point B to E behaves as the plastic in nature. So in between that is B to D, so some point is there point we call as permanent set. So after this point C the material will not go back to its original configuration. So that's why that point we call as permanent set. So ಈ ಪಾಯಿಂಟ್ ಆದ್ಮೇಲೆ ನಾವು ಏನೇನ್ ಲೋಡ್ ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ರಿ ಮತ್ತೆ ತೆಗೆದ್ರು ಕೂಡ it will not go back to its original configuration. That becomes permanent length of the material. So ಅದು ಏನಾಗುತ್ತೆ ನಮಗೆ ಪರ್ಮನೆಂಟ್ ಆಗಿ ಅಷ್ಟಕ್ಕೇನೆ ಫಿಕ್ಸ್ ಆಗುತ್ತೆ length, right? So after this if we apply the load, so after the permanent if we apply the load, so there is a drastic changes in length and the material gets fractured. So material gets fractured means cut ಆಗುತ್ತೆ. So that point we call as the fracture point, right? So this is stress strain curve, right? So ಕೆಲವು ಪಾಯಿಂಟ್ಸ್ ಇದಾವೆ, ಸೊ ಅಷ್ಟನ್ನ ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಲೇಬೇಕು. ಸೊ ಫ್ರಮ್ ರೀಜನ್ ಟು O to A ಏನಾಗುತ್ತೆ, ಫ್ರಮ್ A to B ಏನಾಗುತ್ತೆ, ದೆನ್ ಫ್ರಮ್ B to E, ರೈಟ್? ಸೊ ಇದು 1 ಮಾರ್ಕ್ಸ್ ಗೆ ಡೆಫಿನೇಷನ್ಸ್ ಕೇಳಬಹುದು. ಸೊ ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಅಂದ್ರೆ ಏನು, ಪ್ರೊಪೋರ್ಷನಾಲಿಟಿ ಲಿಮಿಟ್ ಅಂದ್ರೆ ಏನು, ರೈಟ್? ಸೊ ಯೀಲ್ಡ್ ಪಾಯಿಂಟ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಹೇಳಿ, ರೈಟ್? ಸೊ ಫಾರ್ 3 ಮಾರ್ಕ್ಸ್ ಇಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ರೈಟ್? So remaining moduli of elasticity that we will continue in our next, right? Thank you.